Good morning, guys. Today we're going to do a video of memory analysis based on the scenario that I set up in my blog. The title was Set Up to More Memory Forensics. And if you don't know what I'm talking about, you can just go to the blog and take a look-see of the things that we set up before. Pretty quick and won't take you a lot of time. And it's a fun story, so just everyone goes to take a look. Anyways, so as we should with every time we do memory analysis, we should grab the image info of the memory that we are analyzing, just so we can gives Volatility a better chance to more quickly find things because it knows the internal structure of the memory, because different OSs run on different structures, or different memory structures. So here we are, Windows XP Service Pack 3. So we will grab that. And you see here it says suggested profile, so it's not 100% sure if it's 2 or 3, but if you just check down here for image type, it says Service Pack 3, which it grabs from memory, so then that's how you know which one to actually choose. So we will add that to our command line profile. Sorry guys, it's early in the morning, I just woke up. Actually had this ready to go yesterday, but there were apparently some technical difficulties when I was rewatching the video, so I had to scrap it and start all over again. If anybody knows a really good web recording, screen recording software, that would be absolutely great. Anyways, the next step we're going to do is we're going to run the plugin ConScan, which allows us to go to memory and view not only the current connections that were set up, but also the terminated established connections that were set up. Now, if you don't care about the ones that have been previously terminated, you just want to know what was the actual live connection, you can just run the plugin connections, and that will produce that information for you. So if we go back to what we did on the command line on the victim machine, so what it should show is not any of the listening ones, because it's just going to show us the established connection. So it will definitely show us this one, and then anything else could be possibly hidden or terminated connections. So let's just let that run. I'm going to hit pause here. So we have the finished ConScan here, and as you can see, it has the .3 to .2 with the 4444 process ID of 1684. And then we also have this connection, which must have been terminated or was hidden, .3 going to .4 with port 80 with process ID 440. So let's still focus on this one right here, the 4444. And now let's do PS list, which would show us all the running processes on the machine. Oops. Now I should point out that some of these commands might only work in XP, 2003, or Vista, so make sure you read the documentation to make sure you're running the right command, because certain commands will only run in, for instance, XP, while others won't run in XP. So just be aware of that. Get our process list here. Oops. So if you can remember, or you go look on the blog, it doesn't really, yeah, okay, you can tell that we're using VMware here, some VM stuff, but nothing really too, we had the command line up. I had the command line up when I did this, so I was running, sorry, when I was running WinDD, so nothing too crazy. But then when you look at the forensics for the memory dump, you see hxdef100.exe and trythis.exe, as well as the command.exe. So now that is kind of interesting, right? So we didn't see these two in the process list before. So we see this as a process ID of 1684, which matched the process ID of the connection we weren't able to figure out what that was connected to. So it means it has access to the internet, whatever this is. and then we have its parent ID, which is 464, which happens to be right above it, which is hxdef100.exe. Its parent is 676, which is services.exe, and then its parent is winlogon.exe, and then which is sms.exe, which is then system. So this is process ID and then its parent's process ID. So this doesn't look like a good thing. So it looks like what happened is hacker this hxdef100, which anybody who's ever done a little bit of research on this will see this is obviously Hacker Defender, the rootkit, was run at 1357. We have the timeline here, which is good. And then it spawned trythis.exe. So now we don't know exactly what these do, but we can try and take a look. And this says the number of open handles that it has, which we'll see later on, and also the threat. So now let's actually go and look at the DLLs that each of these processes load. So we'll run DLLL, 3 L's, be sure to count them, and then put in the process ID. So let's do hxdef100, which is 464. Now, obviously, I highly suggest when you are actually running these commands for an actual case, I do suggest that you output standard output to a file as well. This way, then you don't keep scrolling back or just copying and pasting from the command line. It's just a little bit easier. And in the Unix world, in Linux world, there's a command called T. It's called Tango Echo Echo. And what it does is that it I'll say it splits the output of a command, and it puts it out on standard output, so it puts it on the console here, and then it also pipes it to a file wherever you want it to go. They have T actually ported over to Windows, and so I highly suggest you go take a look at that. You just do a Google search for GNU32. Let me see, I have it. I just haven't gotten it. I haven't actually set it up yet. You actually have to put it in your path and everything like that. So GNU32, Win32, core utils. So it's what's called core utils-530. So, and then you can port over a bunch more Unix commands, which are usually very, very helpful. It's actually one of the biggest downfalls I feel of the command line in Windows, unless you have PowerShell, is the amount of stuff you can do in Linux, and then when you go to Windows, you just feel so limited. Anyways, here's a DLL list of everything that hxdef100 loads. And the first thing you see here is this document for settings, desktop, Hacker Defender. I'm just going to say that's just easier. And now if you remember, if you go back to the blog, this is on the desktop of the person that was doing the work, and we didn't see this. We didn't see this folder, hxdef100. So therefore it must have been hidden, which is another clue that you're probably dealing with a rootkit or at least something kind of nefarious here. And then you could go and take a look at all of these other DLLs. They're in the right folder, but you can see if certain malware, you usually called all of these together. And then let's go to the trythis.exe, which is 1684. Sorry, I'm drinking tea. If you live in England, you drink tea. That's what you do. Let's pause here. Okay, so these are all of the DLLs that trythis.exe loads. And if you go through some of these, excuse me, I just want you to highlight the rsa-enh.dll and the iphl API DLL. This is has something to do with like security and secure communications, and this is IP helper to API. Now these can be used legitimately in a bunch of things like ls, ASS, exe, winlogon, service host, Explorer, IE Explorer. But however, these two DLLs are also called when Meterpreter is being run on the system. It used to be it was just metserv DLL for Metasploit 3.2 and earlier, but when Meterpreter came, after 3.2, they started using other DLLs. So Meterpreter is basically something that you can run, which gives you pretty much full access to a computer, and it tries to reside mostly in memory, so there's not a lot of Windows artifacts left onto the system. So this could be really bad. This could be actually a reverse shell onto our computer, actually originating from our computer. As you can tell, if you go back to here, it was probably started by us. So that's not good. I also want to point out with the other process ID 464 for the Hacker Defender one, you can see this was the command line that was run in it. So it actually took an INI file, so there was a configuration file as well. So there were parameters passed by whoever set this up to make sure that certain things were hidden and certain things were probably run. Probably just try this.exe, which is apparently in the C path. We didn't actually check that, so it could still be there. Or if they were hiding the Hacker Defender stuff, they were probably hiding this as well, so you wouldn't see it running. And we didn't see it running in the process list either, so that's also a good hint that this is actually hidden. So that's interesting. So now let's see all the handles for each process. So the best way to explain handles is I can consider them pointers. It's a reference to something that's somewhere else, because they can't reference you directly, because sometimes, especially with memory, things are getting moved around all the time, things are getting swapped to the page file and things like that, so they don't actually know exactly where it is, so they have to kind of pass a reference when they're talking about opening objects and opening files and opening threads, so they use handles to do that. And I'm sure there's a better way to explain it, and Google, once again, is your friend. There's Resinovich wrote a great book called, I think it's Windows Internals, and I'm sure he talks about this ad nauseum. I have it, it's just in storage in Germany right now. Anyway, so this is the handles for 464, which is the HSPE dash thing, and you can tell right here this is definitely not a good thing. Opening up threads, as it said before, and it gives the process ID, and it says Windows Station, which is the service-0x0-3E7F $. And what this means is that this does not require any user interaction. It's non-interactive. You can't interact with it via the console or any normal desktop functions. So if you could interact it via the console, this would be changed to WIN-STA0. I know it's a little confusing, but if you deal with Metasploit a lot, they talk about this a little bit more, and once again, I'm sure it's in that Resinovich book. But basically, it's the WIN-STA0 is the only interactive Windows station that you can use to interact with the desktop. This one, once again, like I said, doesn't require our interaction, so it doesn't matter. And I think that's what I wanted to talk about for this one. So once again, these are more strings you could be searching for, and later if you're doing any timeline analysis or things like that. So now let's do the other process. Once again, you would be outputting this all to either separate files or the save file. This way you have it all saved off in case something goes wrong. You know, sometimes Windows hangs, and you want to be able to save off that information and have it for later, because 2 weeks down the road you're not going to remember what you did. So it's always important to take good notes. So a lot of interesting things opened up here. You can see a semaphore for a shell, so probably not a good sign either. Once again, the file, something in the desktop was opened up, and if you recall in the pictures, we don't remember seeing anything opened up in the desktop because it was pretty bare. You see the TCP registry keys being called, which is probably also not a good sign because it means it's dealing with something with the network. Probably maybe some mutex strings you could search for later on if you wanted to. See once again the process ID 1684 being threads opened up, and then Windows Station again. So this is a non-interactive Windows station desktop type thing. If you actually are more interested in understanding the desktop thing, over at securitystube.net, in the Metasploit Mega Primer, Vivek goes into good detail about desktop things and what you can do with it. I highly suggest you go off and take a look at that. It's really cool and it was amazing. I didn't know about these things, so it was really cool to learn about it. I don't remember what video. Unfortunately, the Mega Primer has a ton of videos, so I can't tell you exactly which ones. But if you look at the description, I'm sure he'll say it says what he goes into in that one, so you can take a look there. So the next thing we're going to do is we're going to run service scan. So if you remember from before, we wanted to see what services were running on our machine, and that's what we ran command line to see the running services. Now this one's going to spew out all the services, stopped ones, the paused ones, including the running ones. So this is going to show a lot more information. Luckily, since I've done this now a couple times, I can tell you exactly where the information is and what we're going to need. But it's going to be a lot. So this is a great example of when you would really want to be saving information off to somewhere else rather than standard out, because as you can see, it's a lot of information. So we'll let that finish. And right here is the one that we want. The process 464 Hacker Defender 100 HXD Service 100. It's our own process. The service is running, and this is where it was called from. So now if we go back to our other services, once again, if you had this saved off, you could open up an Excel and you could put it in a list, and then you could just do the running services, and then you can easily just compare. But we don't see anything about Hacker Defender anywhere on here. So another great sign showing that this is definitely something that is hiding itself from the user. Okay, and then the next one we're going to do is driver scan. This one takes a while, so I'm going to definitely pause it. And just search for all the drivers that are being utilized by the system. So I'm going to pause it here. Hey guys, so I'm actually gonna not let this run. Sorry,